Good morning. Today we're going to be learning about systems of linear inequalities, and you will recall that in the past we have done systems of linear equations, and in order to find a solution to a system, you have to, by graphing anyway, you have to graph the two lines and find the point where they cross. Well, in a similar way, we can find the systems or solutions to systems of linear inequalities also by graphing. A lot of it is the same, but as you recall from the previous section, when you graph an inequality, you have shading and boundary lines that either need to be dashed or solid. And so we're actually going to have entire regions that are crossing as opposed to just lines that are crossing. So I'm going to attempt to show you how to do that in this lesson. So here's our first example, solved by graphing, and I have an equation that is in slope-intercept form and also one that is in standard form. So first of all, I'm going to gather some data for myself. And for the first equation, I know that my slope is 2 because of the 2x. And my y-intercept is going to be 0, -5. For my second equation, I know that if I do hide and divide my x-intercept, I will hide the hide the y for the x-intercept. And 12 divided by 3 is 4. So x is 4, y is 0. And for my y-intercept, I will hide the x, and 12 divided by +4 is 3 for the y. So x is 0, y is 3. I'm going to need those points to graph my equations. So then I'm going to get my x-axis, my y-axis, and I'm going to graph the lines in much the same way that I did yesterday. I'm going to go ahead and graph the first one here, the 2x - 5. I'm going to plot 1, 2, 3, 4, -5. And my slope is 2, so I'm going to go up 2 and over 1. Up 2 over 1. Do that again, up 2 over 1. And I'm roughly right here, and that is my line. Now, because it's a greater than, it's going to be a solid, not a solid star, it's going to be a dashed line. So here I go. Oops, that didn't quite work out the way I wanted it to. Let's try that again. There we go. That's much better. So there's my dashed line, and I know that because it's greater than, I should be shading above. But just in case you don't know how to work that out, you can always use the origin as a test point. So I'm going to do that now. I'm going to test the origin. The origin is 0, 0. So I'm going to plug 0 and 0 in for x and y. So 0 for y greater than 2 times 0 for x minus 5. When I do that, I get 0 is larger than -5. Not really sure why I put this parenthesis that is not needed, but there we go. So is 0 bigger than -5? Yes, 0 is larger than any positive number. So that tells me, any negative number. So that tells me that I'm going to be shading towards the origin. So to do that, we're going to grab our highlighter here and see if this works. This is my shading. You don't have to shade it as crazy as I am shading here, but this is my shaded region. These are all, this shaded area basically represents all of the solutions to the first inequality. Okay, all of these points that are in this shaded region are the solutions to this first inequality. All right, so now we're going to go ahead and go to the second equation, which we said is 3x plus 4 is equal to 12. So the x-intercept is 4, 0. So I'm going to go, here's 1, 2, 3, oops. Let's get back to my pen here. There we go. So 4, 0 is right about here. And then 0, 3 is going to be 1, 2, 3, right about there. And we're going to graph that again. It is a less than, so there's no equal to here. So I'm going to use a dashed line again. And we're going to connect those 2 points as best I can. There we go. It's a little crooked, but you get the idea of what it's supposed to be doing. So there is my second inequality. You can see the point where they cross here, but we're more interested in the area where the regions cross. So again, I'm going to go with my highlighter. And we're going to shade, this one says below, but again, we can always plug in 0, 0 if we're unsure. If I plug 0 and 0 in for x and y, then I'm going to get, sorry, this highlighter business is really weird. So 3 times 0 plus 4 times 0. Again, I am testing the origin to determine where I should shade. So 3 times 0 is 0, 4 times 0 is 0, so I get 0 is less than 12. Is 0 smaller than 12? Yes. So again, I'm going to shade towards the origin. And so when I do that, I'm going to get, trying to stay out of your way here, hopefully you'll have a easier time with the shading than I am with this crazy shading here, but I want you guys to have a really clear idea of how this works. I'm shading the entire side where the origin lies because when I plugged in the origin, I got a true statement. Okay, so now what you can see is that this pinkish part is the part where the solutions are to the first equation, and this entire blue part is where the solutions are to the second equation. And so the idea here is that we are now looking for the solution where the two shaded regions are crossing, which you can see is this darker area here. This area, if you will, that I'm just going to outline here, that is the solution to the system. All right, so now you're going to try one on your own, and hopefully you do well. Our last example is going to be working backwards from what we just did. So you're going to have a system that's already graphed for you, and my job is to write the system of linear inequalities for this lavender region, which they're referring to here, where they're joining. So basically, based on the graph, I have to find the equations of these lines. Okay, so what I'm looking for is I'm looking for the slope and for the y-intercept. So I can see for this first line, this dark black line here, that the y-intercept is 1, 2, 3. So it's going to be 0, 3 for my y-intercept. And if I use slope, I can go down 1, and I have to go over 1, 2, 3 units before I am actually on the line. So again, I'm going, starting here at my y-intercept, I go down 1, and over 1, over 2, over 3. So that tells me that my slope is -1/3. Okay? I know that the line is solid, so it's going to have an equal to. And I know that the shading is below the black line. So that's going to tell me y less than because it's below. It's going to be an equal to because it's solid. My slope is -1/3 x. And then my y-intercept is 3. So that is the first equation for the black line. Then for the blue line, I can see here that this is -1, -2, -3, -4. So my y-intercept for this one is going to be 0, -2. And my slope is actually positive in this case. I go up 1, over 1, up 1, over 1. So I'm going up 1 over 1, so my slope is basically 1 over 1, or just plain old good old-fashioned 1. Okay? So let's get this guy out of the way here. So because this line is not solid, it's broken, that tells me that it doesn't have an equal to. So I'm going to get y, oh wow, where did that green come from? Let's not do that. It's going to tell me that y, and because we are shading above the line, it's going to be greater than, but there's no equal to because it's not solid. And my slope is 1x and minus 2 for my y-intercept. So now I'm just going to put those two equations together. And this would be my system that is represented by this particular graph here. So now we're going to have you try a couple on your own. I have created two example problems for you, A and B, and you are to write the system of inequalities for the lavender region, for this region here, and for the darker region here. So good luck, and we'll see you in class.